All right, let's keep on with the graphing. So on number 10, again, we have another absolute value problem. So trying to find some place to do this. Here go my x's. And again, when I take the absolute value of any x value, it turns everything positive if it's not already positive. We are going to have a stretch of 4, and then everything's going to move down 2. There is no left, right. So I will take all of these y values, and they're all about to be multiplied by 4. So multiplied by 4 gives me 8, 4, 3, 0, 4, and 8. All right, so all these old y values are gone. And again, I would start graphing by taking your 0, 0 point and just moving down 2. So this is going to be my starting point. And from there, I'm going to go left 2, up 8. Oh, different color. And then again from 0, 0, I'm going to go left 1, up 4. And then I'm going to go right 1, up 4. And finally, I'll go right 2, up 8, and end up right there. And we're going to get this sharp V shape. All right, let's go with number 11. So this is our piecewise function. So we have our wall at 2. So here goes my 2. And this negative x, or rather negative 1x minus 5 is going on the left side. And the 3x minus 5 is going on the right side. And we're going to start with the negative 1x minus 5. So I'm going to begin at negative 5. I'm going to have a slope of negative 1 over 1, which will go downhill. So I'm going to start putting my other points on there until I get to my yellow wall. There we go. Now I can connect up to my yellow wall, arrow on this side, and it will be an open circle because this is not underlined. So now we're going to do the other one. And I'm going to begin at negative 5, which happens to be a point I've already got. So what's a color that will really stand out? Maybe black. Let's see. There's my negative 5. Okay. And then I'm going to have my slope, a rise over run, and it's going to be going uphill. So from there, I'm going to go up 3 over 1, up 3 over 1. I finally land on the yellow line, up 3 over 1. And then when I connect my points, I'm only going to start at the yellow line and go this way. So I'm going to leave the other black dots on there. Well, I can get rid of one of them for sure, but I don't know what would happen if I did the other one, if everything would erase. So that is my final version. Let's put that yellow line back in there. One thing on the left, one thing on the right. So when you go to 12, my yellow line's at 3, just 1 over. And we're going to put negative 2x minus 1 on the left side, 3x minus 5 on the right side. And I did forget that on this one, because of the underlined inequality, you got to make sure that's a closed dot right there on the yellow line. All right, so the negative 2x minus 1, I'm going to begin at negative 1. Here I am. My m is negative 2 over 1, which is going to go downhill. So from this blue dot, going up 2 over 1 to make sure I get a downhill look. That's pretty good. Going up to the yellow line. Here goes my line. Arrow on this side, and begin, because that's not underlined, I'll have an open circle. And we got another 3x minus 5. Didn't change from the other one, but again, I'm going to begin at negative 5. My m is 3 over 1, which means I need to be going for an uphill look. So putting these dots up. I finally hit the yellow line, but I only want this little piece to it. Okay. And then the other pink dots are not necessary. So I'm going to erase a couple. I can actually erase them all, but I lost my yellow line. So let's put it back in there. Because this one is underlined, Make sure that's a very noticeable closed dot. All right, then we're going to be moving to our polynomials graphing. All right, so these three problems are going to be similar to, or not similar, but they're from our most recent chapter. So in order to graph something like this, I need to know the shape, the y-intercept, and the x-intercepts. So the first two are in factored form, and so that's the nice thing about it, is that I can find the x-intercepts super quick. So what I would do is just take each factor that has an x, I'd set them equal to 0, and here there's technically 3 of these x plus 3's, but I'm just going to set one of them equal to 0, and then 2 of these x minus 5's. And when I do that, I'm going to get an answer of 5 twice, which means it bounces. I'm going to get an answer of -3 3 times, which means it's going to wiggle. And then just going for this one, -1x squared, I could divide by -1, which still leaves me with 0. And then I square root. Remember, we get 2 answers, so a +0 and a -0, which technically 0 is not positive or negative. It's just 0, but we will have a bounce. All right, so let's get that on here. Here's 0 with my bounce. Here's -3 with my wiggle. And here is 5 with with another bounce. So what I don't like about this is that I can't see the shape. So if I just take, that's like a -1, x squared split up, x plus 3 times, and x minus 5 twice. I want to have all the neighbors meet. So first neighbor, and then single person living alone, and then this person living alone. Anything that's separated by a multiplication sign, whether it's invisible or visible, is considered a neighbor. So I'm going to have a -1, and then I have 1, 2, 3, 4, 5, 6, 7 x's, which is going to give me a line that goes down. And then the last thing I'm going to do is take all of these x's and turn them into 0. So I'm just going to write over this. So this becomes 0, 0, 0, 0, 0, 0, and 0. And again, I'm doing that because all y-intercepts have an x value of 0. And if I start multiplying just left to right, we'll have a 0 times a 0 times a 3 times a 3 times 3 times a -5 times a -5. And maybe at this point you realize as soon as I multiply by 0, these zeros right here, the whole thing just becomes 0. So there's my y-intercept, which I already have graphed. So what I'm going to do is get my basic shape going, up on the left, down on the right. But I'm going to use different arrows. So here we go. I'm going to get to -3. I'm there. I wiggle my way through, and then I'm going to have to turn, get here, and I'm going to bounce back off. Then I'm going to turn, get to my next point, bounce back off, and then I can see my my arrows matching up. All right, so moving to 14. So 14's in standard form. So what I like about standard form is I can immediately see the shape. So right now I know my shape is going to be a line that goes up and down. What I also like about it is I can see the y-intercept super quick, because if I go to each problem, or I'm sorry, each x, because on y-intercepts again, x is 0, and I start to put 0 in for all of these x's, all of these terms are separated by addition subtraction signs, are just going to become 0, 0, 0, 0. And so what happens is when I take all the zeros and subtract 75, I get a y-intercept of 0, -75. So here goes that. What I don't like about this is that I cannot see the x-intercepts because it's not in factored form. So what I'm going to do is come back up to the original problem. There is not a GCF in this problem. I always check for that first. And instead, I'm going to group the first two and the last two. And now I'm going to look for a GCF, and I'm going to move way below my graph. So in the first set of parentheses, I can take an x squared out, and then I'm left with x minus 3, which I still have to have an x minus 3, matching parentheses. And then when I go to the second set of parentheses, if you have trouble seeing what they GCF, take this negative 75 and divide it by this negative 3. And I realize this is really spaced apart, but that's going to be a positive 25. And now x squared plus 25, the things that are on the outside, I'm going to draw a bracket, become one factor. And the common x minus 3 is the other one. So now I'm ready to solve. Okay, so I set each factor now equal to 0. I'm going to subtract my 25 first. And when I'm done, I get x equals a positive and negative 5i. It is a solution, but it does not make the x-axis, unfortunately. So for this one, once I set this one equal to 0, I'm going to get x equals 3. Goes here. It shows up once, so that will be a cross. And now I'm ready to graph my shape. So I know that over on the left, it's going down. Over on the right, it's going up. My only point on the left is this negative 75, so I'm going to work my way to it, cross through, come to here, cross through, and it's going to look like something like this. Now, there might be some little, what's the word, subtle turns in there, but I can't see them. I mean, I don't know. So that is number 14. Okay, next problem 15. So the first thing I'm going to look for is a GCF. So just starting first, I do notice with the number, I can divide all of these by a 2. So I'm going to put that 2, where am I going to put that? Down here. And then I also notice I can take 2 x's from both of those. So this is my GCF, and eventually I will get new or additional factors going with that. So just a reminder, we're dividing all of these by 2x squared, which is going to be, as far as my first thing goes, the 2's cancel out, and I'm left with 4 x's. Here, the 6 divided by 2 leaves me with minus 3, and I'm left with 2 x's. And then here, the x's just cancel out, and 36 divided by 2 is a negative 18. And so now this is what I'm going to make my factor x on. So I need factors of negative 18 that make negative 3. And running my factor program, I will see that a 6 and a 3 would work, with the 6 being negative. So going to my parentheses, an x and an x will not be enough to make this. I'll have to have x squared, but then that's enough. So now what I can do is draw my loops to make these numbers. And x squared times what could make a negative 6x squared, so I'd have a negative 6. And then x squared times what could make my 3x squared, and that would be a positive 3. So coming down here, I can bring my factors. And now I have enough to solve. So starting with my first set, factor, my GCF, I'm going to set it equal to 0. I'm going to divide by 2. And then I'm going to square root, which results in 2 answers. So the square root of 0 is 0 twice. 0 happening twice means I'm going to have a bounce at 0. My x squared plus 3, I'm going to subtract the 3. And then I'm going to take the square root of 3, which gives me a positive and negative. I'm going to give the decimal here. It's 1.7, but I'm going to have an I, because I'm taking the square root of a negative number. And unfortunately, i's don't make the graph. And then my last one, I'm going to take this x squared minus 6. I'm going to move up here, set it equal to 0. I'm going to add 6, and then I'm going to take the square root of 6. So the square root of 6, I'm going to get the decimal of this. And I'm going to get 2.4, but I'm going to get a positive and a negative, which are 2 totally different answers. So 2.4 will show up over here, but since it shows up once, it's a cross. And negative 2.4 can go over here, and it shows up once, so it's a cross. All right, that was the tough part. Let's take a look at the shape. So I'm going to get rid of this highlighting line. So I know by looking at this that this is going to be a U. That's regular. That's a nice thing about this. And then if I go to my problem and I make all of these x's become a 0, so I'm going to put it in this box. Sorry, I just